Exploring Ocean Acidification with LiQWYD, created and illustrated by eLabs. Sit back, relax, and enjoy the sciencey knowledge. The magical ocean. The ocean shifts its pH according to the Earth's current climate. Talk about going with the flow. Get it? Because the ocean is water, and water is flowy, and now we know the ocean is adaptable, so it's kind of like the saying going with the flow. No? Okay. Well, moving on. In the climate that humans have lived in, the ocean has had a pH of around 8.2.
The pH scale is measured in hydrogen ions. The more hydrogen ions means the more acidic.
In recent years, the pH has dropped from around 8.2 to around 8.1. This means that the oceans have gotten 30% more acidic. Oh, I forgot to introduce myself. Hi everyone, my name is LiQWYD. Today I'm going to talk to you about ocean acidification, one of the effects from the changing climate. So essentially Carbonella, do you have a question?
Sorry to interrupt, but what causes there to be more hydrogen ions in the ocean?
Great question. This is due to the overproduction of carbon dioxide, aka CO2, causing much more CO2 to be absorbed into the oceans. When absorbed, the CO2 forms hydrogen ions in the ocean. But there is much more to ocean acidification. Let's take a look. When the CO2 goes into the ocean, it combines with seawater, aka H2O, and becomes carbonic acid. A path the carbonic acid may take is to combine with carbonate, which is secreted by marine animals, and become two bicarbonates. But because carbonic acid is an acid, it can be very, clumsy and lose its hydrogen atoms before combining with the carbonate.
Freedom! I want freedom too!
This causes the lost hydrogen atom to be a hydrogen ion, since it is no longer attached to the carbonic acid. And the carbonic acid becomes then one bicarbonate. Soon, the other hydrogen atom is let out too, and the bicarbonate becomes carbonate once again.
Freedom!
But then the hydrogen ions reattach to the carbonate because they find out they don't like being ions and hog the free carbonate once again, and the drama repeats. Because there is now more carbonic acid and hydrogen ions in the oceans, that means there is more bicarbonate. Why this is bad is because there will be less carbonate available for shelled organisms to use to create their shells. This will result in the organisms having smaller and weaker shells and shrinking in population. More acidic oceans also means that their shells will dissolve more too, causing them to have an even tougher survival chance, which is already starting to happen. Here is an example of shelled organisms having their shells being dissolved in Papua New Guinea. Less shelled organisms also means that organisms who rely on them as food or homes will also have a population decrease, and it will cause a ripple effect. This can eventually lead to a decrease in the ocean's biodiversity. However, because with more CO2, that means the Earth is becoming warmer. This means that oceans are heating up too.
It's too warm.
We know that with hotter liquids, it is harder for gases to be dissolved. In fact, more gases would actually evaporate from the liquid. So it could be that as oceans heat up, the overabundance of CO2 won't dissolve into the oceans as much anymore, and instead, more carbonic acid will evaporate. This potentially can slow down ocean acidification, but could fast forward the warmth in our climate. All of these processes that are affected by CO2 are part of large and extremely complex systems. So this comes to say that we don't know what will exactly happen in decades from now. But what we can do right now is to continue to learn about our Earth and help in the best ways we can from what we see now. Thank you so much for watching eLabs. Hope you enjoyed and see you next time.